Hello everyone, I am Nadira Uzal and the topic of my presentation is group theory. Starting with the definition of group, a non-empty set G together with an operation O or star is called a group if the following conditions are satisfied. First is closure property. For every AB belongs to G, A star B will also belong to G. Associative axiom A star B in brackets then star C will be equal to A star in bracket B star C. Existence of identity. If E is an element, then small e will belongs to G will call an identity. If A star E will be equal to E star A, that will be equal to A for every A belongs to G. Existence of inverse. If A belongs to G, then A inverse will also belongs to G. So A inverse star A will be equal to A star A inverse, that will be equal to E. This A inverse is called inverse of A. Now abelian group. A group G star is called an abelian group or commutative group if A star B is equal to B star A for every AB belongs to G. Examples based on abelian group is Z plus, Q plus and R plus are all commutative groups. The set of all M cross N matrices with matrix addition as a binary operation is commutative group. The zero matrix is the identity element and the inverse of matrix of A is A inverse. 1 is an identity, 1 upon A is the inverse of A in each case. Q naught dot and R naught dot are commutative groups. Now the first theorem is uniqueness of identity. The identity E in a group is always unique. In order to prove that, we'll consider two identities E and E dash. So if E is an identity element, then E dash will be equal to E dash E, that will be equal to E dash. And if E dash is an identity element, then E dash will be equal to E dash E, that will be equal to E. So these statements prove that E will be equal to E dash, that will be equal to E dash E. So finally it will be equal to E dash. So we can say that E and E dash are equal to each other, so the identity will be unique. Cancellation laws. If we consider A, B, C the arbitrary elements of group G, then AB will be equal to AC, that will be equal to B, that is the B will be equal to C. And in second, BA equal to CA, so B will be equal to C. So the first is known as left cancellation and the second will be known as right cancellation. Proof based on this. If we consider B the identity element in group G, then ABC belongs to G will be arbitrary. So first is if AB is equal to AC, so A inverse AB will be equal to A inverse AC. So A inverse AB will be equal to A inverse AC. We can write it as EB is equal to EC by associative law, and then B will be equal to C. Again, BA will be equal to CA, so we can multiply A inverse both sides, so it will be BA A inverse will be equal to CA A inverse. We can put A inverse and A inverse together, so it will give BE will be equal to CE, so B will be equal to C. Now examples based on this. Now this next theorem is uniqueness of inverse. Inverse of each element of a group is unique. Proof. If possible, we consider A, B be two elements in order to prove that. BA will be equal to AB is equal to E and CA will be equal to AC, that will be equal to E. So E be an identity in G and BA will be equal to E, that will be equal to CA, or we can write BA is equal to CA. We can cancel out A, so B will be equal to C. This is by right cancellation law. Next is reverse rule. If we consider A and B elements of group G, then AB inverse will be equal to B inverse A inverse. We can prove it by considering arbitrary elements AB elements of group G, and we know that B inverse and A inverse are inverses of A and B respectively. So B inverse B will be equal to B inverse, that will be equal to E, and similarly A inverse A will be equal to A inverse, that will be equal to E. Now by associative law we can write B inverse A inverse, that will be equal to B inverse A inverse. So we can write it as A inverse, that will be equal to A inverse, that will be equal to E, as we know. So AB inverse will be equal to B inverse A inverse. Now next theorem, if we consider G a group and A belongs to G, then A inverse whole inverse will be equal to A. Now proof. Let A inverse be the inverse of an element A of a group G, then A inverse A will be equal to E. To prove that inverse of A inverse is A, we multiply equation number 1 by A inverse whole inverse. So A inverse whole inverse A inverse whole bracket A will be equal to A inverse whole inverse E by associative law. So EA will be equal to A inverse whole inverse. By it can be written as A is equal to A inverse whole inverse. That is the end of my presentation. Thank you for listening.